We've talked about how to migrate quantifiers over ands, ors, negations, implications, okay? All the logical connectives. But one thing we haven't really talked about is what happens when a quantifier is immediately below another quantifier. So what do we do in this case, okay? How do we migrate? The answer is this. We will never ever migrate a quantifier past another quantifier, okay? We actually will never need to do that. And so we're not going to, okay? But I do want you to think a little bit about what's going on. And think about this statement. For all x, it is true that for all y, p of xy holds, okay? Well, that means that p of xy is true for all x and for all y, right? So I should be able to say for all y, for all x, this is true. They actually say the same thing, right? So I can actually migrate a for all quantifier over another for all quantifier, and it doesn't make a difference. And since the beginning, I've actually written them as for all x, for all y, something. I noticed that there's no kind of ordering implied there, okay? So that's why I get away with that, is because the truth is it doesn't matter. Some people actually like to write it as for all x, y, right? So they would actually write this for all x, y, p of x, y, right? And that's also perfectly valid. I'm not going to do that. I'm going to separate each of my quantifiers. But that just shows you that the order really, really doesn't matter. Okay, so now consider this. There exists an x such that there exists a y such that p of xy is true. Okay, that means that p of xy is true for some choice of x and y. And it really doesn't matter which one I choose first, right? So I could say there exists a y, choose y first, such that there exists an x such that p of xy. Okay, I could have done that. In general, what we do is we say there exists an x, there exists a y, such that p of xy, and we don't bother putting the extra set of parentheses because it's all the same. But now, think of this statement. For all x, there exists a y such that p of xy, okay? Or there exists a y such that for all x, p of xy, okay? The second one is actually somewhat stronger, right? Because what it says is that the same y works every time, okay? So this is one y that works for all. But in here, we have the y may depend on x. Notice, I'm not saying that it does depend on x, simply that it may depend on x, right? Because of that, these two statements are not equivalent, okay? One of them lets me choose a different y for each x. For example, for all x, there's always a y that is larger. That's true. So for all x, there exists a y such that x is less than y. But if I have to choose the y first, I can't make that work, right? Because there is no single choice of y that is going to be bigger than all possible x, okay? So this is a case that actually shows that you cannot migrate a for all in front of a there exists, or a there exists in front of a for all. Once you have quantifiers that are different, you simply have to leave them alone. You cannot migrate one past the other.